Hello, ladies and gentlemen. Welcome back to Math 20-3, Chapter 4, Section 1, Scale Drawings, Part 2. Now here, we're talking about scale and ratio. So we just talked about ratio and proportions. Here, review of ratio and proportion. Now moving on. Here's another question for you. This model airplane kit is a 1 to 48 scale model kit. What does that mean? The 1 to 48, that means one scale foot, S-C-A-L-E, equals 48 real feet. So if the model is 1 foot long, in reality, the real thing would be 48 feet long. Okay? So if the model is 2 feet long, the actual thing would be 2 times 96 feet long. Now, when we want to enlarge or reduce an object by a certain amount, we use the scale factor. Okay? Now, scale factor, a number by which all the dimensions of an original figure are multiplied to produce an enlargement or reduction. All the dimensions are multiplied by that number. Okay? So, usually, scale factors are expressed as ratios, but we can also express them as fractions. Just screw them up. To do so, we put the first number as the numerator and the second as the denominator. So, for example, a 1 to 48 scale model is 1 to 48, but I would often write that as 1 over 48. Okay? Now, technically, this fraction is called the scale factor. Is it a big deal? No, but will I throw that definition at you? Yes, I will, because I'm a pooh head. Now, how do we use scale factors? Well, we simply multiply the dimensions of our original by the scale factor. This will give us the dimensions of the new object. Let's do an example. For example, I want to make a bigger toy box that looks the same as this one. This toy box is 1 foot wide, 3.5 feet long, and 1.5 feet tall. I want the scale ratio of my new box to be 2 to 1. What will be the dimensions of my new box? The original box is 1 foot wide, 3.5 feet long, and 1.5 feet tall. The scale ratio is 2 to 1. Now, so scale ratio is 2 to 1. Turn that to a scale factor. Correctness or something kind of this factor 2 to 1 or 2. So I should change that. So everything here. So my scale factor is 2. So all my numbers get multiplied by 2. So it's no longer 3.5 feet wide. It becomes, the new one is 7 feet wide. It's no longer 1 foot deep, it becomes 2 feet deep. And it's no longer 1.5 feet high. It becomes the new one, becomes 3 feet tall. Twice as much. Okay? Got it? Good. Now, for enlargements, the scale factor will be greater than 1. Like 2 over 1, which is 2, twice as big. Okay? For reductions, scale, my apologies, for enlargements, the scale factor will be greater than 1. For reductions, the scale factor will be less than 1. We just did that 1 to 48 airplane kit, which is 1 to 48, which is 48 times smaller. The model will be 48 times smaller. Right? So, scale factor greater than 1, it gets bigger. Scale factor less than 1, it becomes smaller. Note that. Now, another example. Antonio sends a selfie to his friend. His friend wonders how tall the truck is. He knows that Antonio is about 180 centimeters tall. In the photograph, he is 0.7 centimeters tall. The height of the truck is 2.5 centimeters in the picture. How tall is the actual truck in meters? This may be a little puzzle for you. There's Antonio's friend. Sorry, Antonio. It's this tall, 0.7 centimeters. Then you measure the truck. And the truck, in the picture, in reality, it's 2.5 centimeters. So, Antonio is 180 centimeters tall in reality. How tall is the truck? The actual truck. So, okay, I'll give you a moment to get that copied out. Now, the math isn't hard, but pay attention to how you set it up. Remember we just did all of this ratio and proportion questions? Well, here's where it comes in handy. So, I want to point out this is a reduction. The truck is actually bigger than 2.5 centimeters. Now, here, I'm going to do picture over real. Okay? Now, do I have to do it this way? No, but I know my picture, Antonio, is 0.7 centimeters tall, and in reality is 180 centimeters tall. Antonio. And then there's the truck. The picture of the truck is 2.5 centimeters tall. And how tall is it in real life? I don't know. What do we call a number we don't know? X. Now, this is why we did all those ratio and proportion questions. Evil is just preparing you for the questions. So I'm going to pause for a moment. I want you to look at this and go, how do I solve this? Oh, yes. Cross multiply. 0.7 x equals 2.5 times 180. Now I can't do that in my head. Grab Mr. Calculator. Times 180. 180. 450. So, how do I get rid of times 0.7? Yes. Divide everything by 0.7. That's good. I'm going to change that to red. Just, my apologies, ladies and gentlemen. Now, how do I get rid of times 0.7? Divide both sides by 0.7. So x equals 450 centimeters. Sorry, I forgot my units. Divided by 0.7, which is 642.8. Alright, so far so good. Now, one little thing, the answer is supposed to be in meters. Well, how many centimeters in a meter? There's 100 centimeters. You should remember that. Centi means 100. So you divide that by 100, you get 6.4 meters. I'll get to the truck. Which is reasonable. Look at this. I'll pause that. So when you look at that, go, yeah, if Antonio is like 1 point something meters, and yeah, that's reasonable. Something like 4 times, 3 times bigger than that? Yeah, I believe it. Alright, so far so good? Alright, so take a good look at this. If you got any questions, shoot me an email. Otherwise, go on to the last couple of questions. Alright?